Hello and welcome back to Lesson 11.3, Solving Linear Systems by Adding or Subtracting. This will begin on page 29, and here we go. So here on the very first page, you see it asks us to look at a system of linear equations. So as we look at these, notice how there's some x's and some y's, and they want us to pay particular attention to what we notice about the coefficients of the y terms. So we'll kind of shift our attention to those. What are some things you notice about the y terms? Remember to eliminate, which is what we're going to be doing today in this particular lesson, means that the variables will essentially cancel out. In this case, 2x minus 2x would be 0. Essentially anything, whether it's 2x minus 2x or let's say 5y minus 5y, would essentially cancel out to be 0. So, what are some things you notice about the terms for y? Specifically the numbers next to y. I'll let you fill that in. Hopefully you notice that they both seem very similar, only one is positive, one is negative, and they are definitely going to eliminate or cancel out. So, essentially, we're going to find the sum of these terms. What would 2x plus 3x be? What would 4 minus 4 be? Hopefully that was apparent that we are going to cancel those terms out, because that's what elimination, which is what we're going to be doing this lesson, is all about. Also, it eliminates to be 0 anyways. And then last but not least, what would negative 10 plus 5 be? Hopefully when you work this out, you found that to be 5x, of course 0, and negative 5. So the next thing they're going to do is ask us to solve for x. So just so you know, anything added to 0 is going to be the exact same thing. Okay, so if it was a 6x or 7x plus 0, it's going to be that 6 or 7x there. So it doesn't matter what you add to 0, it's going to kind of be the same. Now, if I have this 5x equals negative 5, think about I am multiplying by 5, so I could do the opposite of multiplying, which is, or I can kind of play a little guessing game, 5 times what gets you negative 5? What do you guys think? Well, if you're wondering, well, I think it's 1, but I'm not quite sure about the sign. I like to use this as the multi-DV man. It's something I used when I taught at other schools. See, it's a multi-DV man. It's a little cartoon I made students kind of use. But you'll notice there's 2 negatives and a positive, and this is how I help them use it. So here I have a positive 5 and a negative 5, so I'm going to cover up a positive and a negative. And what is left over that's not covered up? A negative. So that means that yes, 5 times 1 is 5, and because it's a negative 5, I'm going to be making that one a negative. All right. So notice here, they did graph it for us. They did show us what our solution would be. We could actually, it says, use a value of x with either equation to find the equation for y. So we're going to find the value for y. Notice how I just copied down, I believe, the second equation. You can use either one, by the way. So I copied down 3, left a space for x, plus 4y equals 5. So I'm going to plug that in, and let's work this out. What would 3 times negative 1 be? Hopefully you got negative 3. Let's move over that negative 3. What's the opposite of a negative 3? Plus 3. So that's going to cancel out, and we're left with 4y. What's 5 plus 3? 8. So think about it. 4 times what gets you 8? Hopefully you got 2, because 4 times 2 gets you 8. So now I have this graph. Essentially, the answers I got for x and y, do they match? Well, as you can see here, my coordinates are -1 and 2, so yes, they do match. So another thing you could do in addition to graphing, in addition to substitution, is elimination. All right. Awesome. All right. So here we have explain 1A, solving linear systems by adding. So first step we're going to do is we're given a system, 2 equations, and we're going to be asked to add. So let's first take a moment to see which variable we think might eliminate. Do you think it might be the x's or the y's? X's or the y's? It's the y variable. So what we're going to do is we're going to write down our equations, and we're going to combine like terms. So we're going to combine 1x and 2x. Yes, that is a 1x there, even though they don't put it originally. Make sure you're writing a 1 there. Take a moment to add that together. Hopefully you got 3x. Since these will cancel out to be 0 anyways. And then 5 plus 4, which would be 9. So think about it. 3 times what gets you 9? Hopefully you got 3. 3 times 3 gets you 9. So now that we found out what x is, again, you can use either equation. I just chose the top one because it seems simpler. There was positives, the numbers are smaller, less steps probably. So that's why I chose the first one, just in case. But you could use the second one if you'd like. You'll get the same answer. So instead of putting x, I'll put 3. What's the opposite of, think about it, 3 plus what gets you 5? 3 plus some mystical magical number gets me 5. I wonder what that would be. Hopefully you thought about it and got 2. So that means our solution would be 3 for x and 2 for y. All right, moving right along. You can check your answer by graphing. In fact, if you'd like, we'll use Desmos to kind of just check that really quick. So we're going to use Desmos. It's desmos.com. We're going to press Start Graphing. So this is an internet browser you can use, or internet application you can use to kind of just check your answers. So here we had, let me just zoom this in a little bit so we can see it a little bit better. We had 2 equations and we got an answer. We just want to make sure if it's the correct answer. So x, I'm going to use the keyboard, x plus y equals 5. And for my next equation, that's 2x minus y equals 4. As I can see, they do cross, and they do in fact cross at 3, 2, which is coincidentally what we got here. So that's just a way you can kind of check by graphing. For our next problem, which is solving a system by subtracting, we'll see here we want to know which variable kind of eliminates. So here, let's take a look at our x's. Probably not, because they have to have the same number and different sign. The y's they do have the same number, but they just don't have opposite signs. Like one has to be positive and one has to be negative, right? So neither right now. Wah, wah. But we could eliminate if we just made one term negative. In this case, it would be the y's. So let's go ahead and do that. So 3x plus 2y equals 5. So what we're going to do for the second equation is we're just going to multiply this by a -1, essentially subtracting the terms. So take a moment right now and let's think about what each one of these would be. So what would -1 times 1x be? And then -1 times 2. Notice how we're just changing the sign. So that +1 became negative, that +2 became negative. And what do you think is going to happen to this -1? It's going to become positive. So essentially by subtracting, we're just changing the sign. but kind of keeping the numbers very similar. All right, let's take a moment and let's think about what's 3 take away 1. Hopefully you got 2. Now our y terms will cancel out. And what's 5 plus 1? Hopefully you got 6. So 2 times what gets you 6? Think about it. Hopefully you got 3. So again, you can use either one of these to kind of solve for y. I'm going to choose the first one. 3 times x, instead of x, I'm going to write in 3, plus 2y equals 5. What's 3 times 3? 9. What's the opposite of adding 9? Subtracting 9. So that'll cancel out, and I'm left with 2y equals, what's 5 take away 9? Negative 4. Think about it. 2 times what gets you negative 4? Again, there's that multi-DV man. If you're like, I think I know the number, but I'm not sure of the sign. So I do have a negative and a positive. What do I not have covered up? A negative. So that's a negative 2, because 2 times 2 is 4, and since it's a negative 2. So that means we have our 2 answers, which in this case are 3 and negative 2. Feel free, I'm not going to do this on screen, to use Desmos if you'd like to kind of check to see if your answer is indeed 3 and negative 2. With that being said, let's go on to a word problem. Oh yes, very, very fun. So here we have, again, perimeter problems. A rectangular picture frame is 62 inches. The difference of the length of the frame and twice its width is 1. The system is as follows, where L represents the length in inches and W represents the width in inches. And what is the length and width of your picture frame? So first of all, we're going to take it step by step, but which variable you think eliminates? So let's look at the L's and let's look at the W's. Which one do you think eliminates? It's going to be the W's, because 2 here is positive and then the 2 here is negative. They will cancel out. So let's go ahead and do that now. What is essentially 2L plus 1L? If it helps, put that one in. So 2 plus 1 would be 3. The W's would cancel out. Here I have 62 plus 1, which would be 63. So think about it. What times 3 gets you 63? 21. So again, you can use either equation, top or bottom. It doesn't matter. In fact, let me just fix one slight error, the fact that that should be an L and not an X. So instead of writing L, we're going to write in 21 plus 2W equals 62. So I did opt for the top equation. 2 times 21 would be 42. What's the opposite of a positive 42? Negative 42. That cancels out. 2W equals, what's 62 take away 42? 20. And think about it. 2 times what gets you 20? Hopefully you got 10. So that means our length and our width are as follows. And feel free, if you'd like to kind of graph to check that. We'll be back with another video to go over the checkpoint as well as the homework.